Hey everyone, so today's video is going to be discussing a little more detail into what we discussed recently in interset rest time. So how much rest you need between sets when you go in for your workout, and what's kind of the, I hate to say about optimal amount of rest that you need for your workouts. Now, of course, we looked at the literature, we looked at what the science, the studies have actually said when it comes to that, but this channel is not just about just explaining what the science says. It's more, well, I shouldn't say more, but it's equally also about understanding how the body functions, physiology. So, well, physionic, that's the whole point of physiology. So in this video, we're going to go into the actual details, the nitty-gritty of what's happening in your cells and give an actual why we need to rest this particular amount of time for each condition. So if you're interested in that, finding out the actual physiology and cellular biology, things like that, so you're far more educated and kind of can extrapolate other information off that, then you've come to the right video. So without further ado, let's jump right into it. In a previous video, we discussed how longer rest times tend to be more advantageous for strength training and potentially for bodybuilding purposes. However, it was relatively ambiguous for single repetition sets, with short rest times being sufficient recovery between singles. However, we did not discuss why this is the case, beyond expressing what the literature shows. So, let us ask the question every human being should be asking in any situation. Why? Why is there a difference? The answer lies in the bioenergetics of the muscle cell. So, let us investigate. As we know, ATP is the molecule necessary to make our muscles contract. We have a tiny amount of ATP at any given moment, and that ATP is used in a second or two of movement, not long enough for us to complete anything. Fortunately, your body's also equipped with a ATP buffer called the phosphocreatine system, and this system allows your cells to create more ATP in the blink of an eye by phosphorylating ADP. This system has sufficient phosphocreatine for about 10 seconds of movement. This is likely enough to complete a single repetition, like one might use in a powerlifting modality. For the training that extends beyond a single repetition, our cells employ anaerobic glycolysis, which is another very quick system of energy. But as a consequence of that particular quick energy, there's a production of hydrogen ions. Hydrogen ions decrease the pH of the muscle, making key enzymes less able to function as enzymes function optimally within a strict pH. This acidosis builds with each continuing repetition. Not only that, ATP is not as readily available. So, between increased acidosis and decreased energy in the muscle, it takes more time to raise the pH of the muscle and regenerate energy in the muscle. This is a major reason we breathe heavily after exercise, even short bursts. Now, we have a base knowledge of the physiology, but how does this clearly apply to our scenarios? In the use of singles, acidosis is minimal, so any ATP used is free ATP and phosphocreatine driven. Therefore, less time needs to be taken between sets as there is less of a need to return to homeostasis for optimal performance in the following set. In the use of multiple repetitions like 5 or 8, free ATP is used, phosphocreatine supplied ATP is used, and glycolysis is running maximally. So not only does the muscle need to recover from energy depletion, but it needs to clear hydrogen ions to raise the pH for best possible performance in the following set. As there is far greater acidosis, you can expect a longer rest time to be needed. This is likely why shorter rest times lead to decreased repetitions per set after initial, since hydrogen clearance and energy state haven't reached homeostatic levels. These are all critical physiological outcomes, but another factor is psychology. If a person is lifting a maximum repetition, is it likely they'll be able to muster the mental fortitude to re-engage the same weight 60 seconds later, even if their physiology might allow it? Unlikely, although possible. So psychology certainly plays a role. Also, keep in mind that these systems can improve, just like they can worsen. So a value of 1 minute may be more than sufficient for one person, but less so for another. Or in multiple repetitions, a complete recovery could be made in 3 minutes for one person and 5 minutes for another. There are without a doubt several considerations, but from a bioenergetic standpoint, the limiting factors come down to energy availability and in some instances, acidosis. And that's the video. So obviously everything is rather multifactorial, but when it comes to the actual physiology, if we talk about within the cell or within the whole body in general, it comes down to two main drivers of fatigue. So ATP, so how much ATP or free ATP that we have, available ATP that we have, as well as when we're talking about multiple repetitions, especially as we keep increasing our repetitions, we're talking about acidosis, so certain levels of metabolic acidosis. So without further ado, I think we can go ahead and finish this video out. But of course, if you want to know more details, then you can ask questions in the comments below, as well as read my article, which is free and has all of my peer-reviewed sources for you to go through as well. Hopefully I'll have the pleasure of seeing your face in the next video, and I hope that you have an awesome day. See ya.